Hi, Ethan. I came across a really interesting document recently. It was called Building a Sustainable Future, The Role of Data in Green Construction. It's an Autodesk white paper, and it talks about how it's important for us to make sure that we include data in our designs. And I think we've talked about it before, building information modeling, BIM. And to me, the information is the most important part of all of that. And I heard someone say it the other day in a conference I went to, that I is the most important part of the whole BIM process. Because if we don't have the information attached to our objects, we can't use all the other stuff. But I thought this was a really interesting document. It does seem a little bit wayward in that it loses a bit of direction, but it talks about the need for construction. It talks about green construction, focuses on sustainability. Knowing the inputs to construction is an important part of this. So, for example, we need to be able to record the data. We need to know about the construction. You can't minimize the effects if you don't record the information. And the data has to be shared with others, between the architect, the owner, the contractor, and so on.
Yeah.
I also thought that a big part of making sure our buildings are sustainable has got to be site analysis.
Yeah.
That if we don't do a good job of our site analysis, we lose the opportunity to reduce the waste long-term in the use of that building. So again, it's data that we're collecting. We're collecting information about the site, wind, noise, sun, all that kind of stuff. The document talks about reducing waste on site. And to me, this is a really difficult one to reduce the waste. There's only one contract or one project I've ever been to that was really set up to reduce waste on site. And that was the building that you and I visited in Wellington, I think it was.
Mm-hmm.
The Furry Building, the sustainable building in Wellington, Victoria University. They went to a lot of trouble to reduce waste, not just the waste in construction, but waste in the future as well, making sure that was a green building for a long period.
Yes, so it's quite an interesting project.
Yeah, I thought it was a really interesting project. Maybe we should talk about that one day. But the other part of site analysis, of course, is the site impact. Better landscaping can improve the building's impact, and the site location can help. For example, collecting rainwater, making sure that we've got permeable surfaces to allow the water to trickle through so we don't have a stormwater collection problem. I think a lot of this, it's easy, I think, for us to apply a lot of these lessons to a single large construction commercial building. But actually, there's a lot of small individual domestic projects that should really apply a lot more of this information. If you look around, people put concrete driveway, concrete parking area. Where I live in Napier, a lot of people are dividing off their back section and putting another house there. But the area is almost totally concrete. Where's the permeability? Where's the ability to allow the water to seep into the soil, to feed the environment? No, what we're doing is we're putting it in the drain, goes out to the street, goes into the stormwater, and where I live in Napier, it's pumped out to sea. So that, to me, that would be something that we should be looking at. How do we then analyze the site and improve through a design so that the environment is better served, that the sun comes in at the right angle, we get the roof overhangs correct, we don't have to have too much air conditioning in the summer, we don't have to have too much heating in the winter, let's reduce our energy usage, but also make sure that we're doing the other things that people don't think about, rainwater harvesting, grey water harvesting, stuff like that. In this document, they talked about how much energy construction or how much energy is used by the environment, by everybody. For example, they said renewable energy accounts for 22% of Japan's total electricity generation. We're really fortunate here in New Zealand.
Yes.
10% of electricity is from renewable resources.
That's what 2022 data, I think. Well, I think maybe more.
Which is a pretty high amount.
Yes.
There's still room to go. Yeah, there's still more we could do. For example, why isn't every new building in New Zealand required to have some PV panels on the roof to improve the when I used to fly in from my trips, there's a sea of roofs baking in the sun, and hardly any of them have got PV panels on them to get some energy. New Zealand's, I did check, 40% of all energy use in New Zealand comes from renewables. So that includes everything, the construction industry. You need a truck to get stuff here, you need a truck to get stuff there. So there's a lot of energy use, which is not just electricity in New Zealand. So we do need to look out for that. So back to this document, it seemed to me that the document was really focusing on making sure that we collect the information and we use, obviously they want us to use their CAD product to collect that information together. But then we could use the embodied carbon and construction calculator to then look at how much embodied carbon we've got. Now, we've got our own one in New Zealand. The Autodesk one was EC3, the embodied carbon and construction calculator. But we've got one from the New Zealand Green Building Council. So there's an embodied carbon calculator, which we can then install and we can start to look at. But of course, how can we use that, Ethan, if we don't have a CAD program or a BIM program that allows us to calculate or collect information about the materials?
New Zealand Green Building Council. So it is what I understand is it's a database. You need to download the software, and it is a database of materials in New Zealand. And it talks about you can select if you use this kind of brick, and it has a calculations of embodied carbon. What will be embodied carbon? And also it plays a role where you want to install. For example, you want to source the material from Auckland and install in New Plymouth. That's a lot of transportations. You're burning energy, something like that. So that also think about one of the factors anyway. And so New Zealand Building Council is doing a good work, and it's a part of their research and the database bank, data bank for that. For Autodesk EC3, which also called Embodied Carbon in Construction Calculator. That one I haven't tried yet. I have the link, but I haven't tried yet. I believe that it's going to be the same thing, similar things like a New Zealand one. But yeah, it's things, again, we need to have information to feed back and forth. We need to do research too. It's going to be an iteration process, because if you use this material, what is carbon? If the client's goal is to, let's say, was a home style or something like that, you need to meet certain standard. You need to optimize your resource. Otherwise, what's the point? Because you can build a house anyway, but if the client's demand for it, if the market demand for it, for example, it may be the client's sales strategy or government vision. So we need to strive for it. Now the tools are coming to there are so many tools are available, unlike a few years back, because we don't even have it, isn't it? For that kind of things. We have no idea how much energy burned to get a clay brick, isn't it?
No. The tools are becoming available, as you say, but they're useless without the information about our project. So, for example, we can find out how much energy is in one brick, how much embodied energy is in one brick, but how many bricks are in my building? That's where the data comes from, surely. And if we don't tell the BIM program that this wall has bricks on it, then it won't report that it's got bricks. So we do need to make sure that when we design, and this comes back to, I think, a discussion we're going to have in the future about levels of development. Yeah. That we need to make sure that we're at the right level of development so that we can then extract the information we want about the materials we're planning on using. For example, even in landscape, if you're starting to build a design and you could say, for example, here's the front entry, it's got metal gates, I need lighting. How many lights do you need? There's a calculation. You need to be able to calculate how many lights there are. Oh, there's granite on the top of the walls for protection. Or then how much granite? So we need to be able to quantify all of these components that we're thinking of using. And so we need to make sure that we attach the information to those objects. They're not just extrusions. They might be a hardscape. It might have a bedding material. If we use the right materials can now start to collect the embodied carbon. So we could actually take that information from the carbon calculator, apply it to the material that we are putting on that particular block wall, and we would be able to know how much carbon was embodied in that design. Now, of course, if we're doing landscape, we could also look at the plants we're putting in and the trees we're putting in and look at how much carbon uptake they are taking. And we could compare them to each other and see whether we're producing a carbon neutral design or not. But again, it all comes back to data. And so they're quite right. This is Autodesk's Construction Cloud white paper. They're absolutely correct that the data is got a massive role in green construction. You can't expect to sit at a drawing table with a T-square and a set square and then be able to calculate the carbon usage of your design.
Yeah. A few years back when we start using BIM, the information that we feed is how many to extract out the schedule quantity, how many dose, what the flow area is, what the roof area is. Okay, we assign the materials, but now we can go for another steps. The materials, the question marks, is it carbon neutral? What is the embodied carbon for the material that assigned, and what the number is ultimately? A few years back, 20, 30 years ago, we talk about when architect draw lines, that lines has some money attached to it. Now, not just the money, it's also about the carbon, embodied carbon attached to it. So it's another dimensions in architecture.
Yeah, and it is all about the information. We used to say that when an architect drew a line, that line represented something. Now we're saying not only does that line represent something, but it represents this, and it's this volume, and it's this material, and therefore it's this much carbon embodiment.
Yeah.
So it's, I mean, that is where we're going. Their computers are getting faster. They're able to take care of a lot of this information now. Yeah. So what do you think? Do you think Autodesk will write?
Yeah, it's true. Yeah, it's important. All about data, all about information.
So we got some good topics coming up. I was just going to focus on some of them. So one of them coming up, I'm going to see a laminated veneer lumber construction company, our local one, and they were going to talk to me about sequestering carbon in the timber. I'm really looking forward to seeing that. So look out for that. So don't forget to subscribe to our Spotify. Go to Spotify, subscribe to this podcast so that you get notified every time we upload a new podcast.
All right.
Thanks for your time, Ethan.
And see you next week.